After finishing with the linear regression model, now I decided to keep the model column which I initially in the first attempt I dropped that. So but I decided here to keep that model. Also I changed the algorithm. Here I am using random forest regression. I also imported the basic library. Then I load the data. This data set is different. This data set is not in the previous one. Here I have the year column, also the model column. So I keep those two columns. Now here I am creating a dictionary for every individual for the categorical column. The reason for that, for keeping this value, the value will be keeping the class name, because for the encoding the categorical column I am not using the one-hot encoding here, but I am encoding the label encoder, scale and preprocessing dot label encoder. What this label encoder does, for that I have created another notebook. Here I have created a simple data frame with column 1 and column 2. So I can see that there it's a simple data frame with two columns, and both columns have some categorical value. Some first column has black, white, pink, black, white, some colors name, and second column has some transportation vehicle name like car, bus, taxi. Now I have imported the label encoder, which I am used on my main dataset. But before that, I am showing here what is the main does. Here I am create a basic insert of label encoder. Then I am creating another column here. I am creating another column on this data frame with using label encoder dot fit transform on the first column. So I am creating another column which I have named this column 1 encoder, and I am applying encoding on this column only, column 1. So what will happen when I do this? This column will created, and it will create some numerical value. This numerical value are representing this categorical value. What category? Like this black shifted to the 0, white shifted to 2, pink shifted to 1, white again 2. That means when it comes to so when it find white, it put 2 here. When it find black, it put 0 here. So label encoding has an attribute called private attribute called classes. So I can, if I apply that, I can get 3 classes name. So in case our model or my data frame has 5 rows, but it returns only the unique value like black, pink, white, black, pink, white. But some of the classes are repeated, like black is repeated 2 times, white is repeated 2 times, pink is 1. So it is return me only 1, only the unique value. So that means label encoding is doing what is doing. It is doing it is converting this categorical value into a into integer form. This is what doing. And I am creating a label this into this, and then I have run a simple for loop on I have used enumerate purpose that to get the index number from here. Then I am adding the numerical value on the dictionary. Here I can see that I have get the dictionary. For reason that this one will be, so I can see the black is 0. So then when it come to the black, it encoded it as 0. So when it one is pink, it shifted it put 0 1 here. So when it's white, it put 1. So whenever it find white, it will put 1. So this is what label encoding is doing. Again, I have created another column for call to. Here also showing that car, bus, taxi. Here only 3 unique vehicles here: bus, car, and taxi. And some of are repeated, like car is 1, bus is 0, taxi is 2, again taxi is 2, and car is 1. So this is what label encoding is doing. Here I am applying the same process I just shown. I have created every separate dictionary for every categorical column. For reason that for keeping this dictionary, this will help me to build the web app. When I will build the web app for and host it on website, so other people can put some information, this type of information, so they can get an idea what that car price can be. For in that time, I need this. So that's why I am keeping this. This has no use on the model creation. So here I am imported label encoder. Then I have created an instance of label encoder, and then I have creating another column for every category column. Here I am creating a brand encoding column for the brand column. I am creating the body encoding column for the body column. So in that way I have created all all new column for the every categorical column. Here I can see that after the run the function, I have get another column which are encoded in a numerical form, like brand encoded column are shifted. Also I have used drop the, because I no longer need this categorical column, because more machine learning model can't work with categorical value. He only understands the numerical form. Now again I have take the x and y. X are nothing but features, which is mileage, engine volume, year, and these are, and y is also my target column, which is price. Here I can see that I didn't shift to the log price, because I leave it as the original price it is. Because the reason for that, here I am using the random forest regression. Random forest regression is a tree-based model, and tree-based model does not affect it that much with outlier. Also, tree-based model does not require scaling of our original numerical value. It's work completely fine with the original data. Again, I have imported train test split for splitting the dataset in training part and testing part. For after creating the model, I can evaluate the model model performance on the testing purpose. So that's why here I have the same number of data as I had previously. Then I am importing the original algorithm. Here is the random forest regression. First, I have created an instance of random forest regression. Then I have used .get params to get the parameter. These are all parameter of the random forest. I can change these parameters from something else to get some other value. So to regularize the model. First, I am not tune any hyperparameter, because I leave it as the default parameter is. Then I feed on that default algorithm. I have feed the x10 and xy. Then I am checking on the train. Again, I am doing first one training, predicting on training data. Then I have imported cost function, mean square error. I have taking the root mean square error by wrapping up the mean square error by np dot square root. Here I am getting the mean square error is only 1947. So the difference I can see the huge. Initially when I had in a linear regression model, so there my training error was 10,000, but here it's only near 2,000. 8,000 difference the random forest regression gives me. Then also I am predicting on X phase. Here I can face on test set the model also less. Here near 5,000, 4,800. Initially my linear regression model, my testing error was 11,000, but here is only 4,000. So sure, random forest regression work very well on the data. Then I am checking the R2 square. R2 square, the training R2 square give me 98%, 98, while the initial linear regression was give me near 75, but random forest give me 98. So difference is very huge. Also testing R2 square is also fine. This is 94, so I cannot say this is a overfit model, because I am getting very good result on testing data also. Now here I am plotting the curve. So near if I put a 45-degree line, so I can tell that most of all the data set are near to or on the 45 line. So there are no any spared on the data points on the graph. If I compare this graph on linear regression graph, so clearly see the difference here, how much better perform my random forest regression are. Also I plotted the residual. My residual is very narrow. Residual graph is also very narrower. Most of the data points are very near to zero, mean is zero. So it is a good sign that most of the data points are correctly predicted. The prediction errors is not good. I can see some dispersion on the test data, but not that also again, but these are also are fine. Now I am creating the same data frame, the DDF eval for random forest regression. Here I am checking the difference. That then I have apply the describe method on the describe method. Here I can see the mean difference is 0, almost completely 0. Some, that means some prediction is predicted as the original price is. There is no difference on the prediction value and the target value. And also the maximum prediction is very less, like 510. Like the maximum price was 125. As this data for the random for the linear regression, for this, where the difference was 17, difference was 84,000. In case of random forest, the difference is only 4,800. So the difference is very huge for compared to linear regression and random forest regression. After seeing that, I decided to hyperparameter tuning to if I get some generalized model from it. So I have set some parameter on. I have plotted some parameter for that. I have used the max depth 10 to. This max depth will indicate that how much the depth that one tree of, as random forest regression is a tree-based model. So it is only construct some lots of decision tree inside of it. So how much the tree depth will be? So it will be taking this value one by one to find the good one. Then I have used randomized search CB. Initially I didn't use gift search CB because gift search CB takes a long time, but randomized CB take a little bit less than compared to that, so I have used that. After fitting the get, I have get some score. There I am getting base estimator, base param, and base score. Base score is getting, I am here 92. After that, I am checking the mean square error on the train data. Here I have got the 630. So surely I have got very good on result on training data or by tuning the hyperparameter. And also I reduced some of, not much, but I have reduced some. Like initially the my base model give me target where it is here. My base model give me 4,800 RSME on the testing, but after the tuning the hyperparameter, I get 4,100. So I reduce 700 from here. But now here I can see them say that my model is little bit overfit, because on the training set it give me very less error, which is 600 for 600, and in the testing time it give me 4,000. So the difference is very huge here, 600 to 4,000. So I can now say that this model, after tuning that, this model get overfit. For taking care of that, I have used git search CB. Again, I have plotting some neighborhoods parameter as I am find from here. Here I am found in estimation 200, so I have put some data from near the 200, like 100 and 150. I have used all the for others also. Then I applied git search CB here. After performing the git search CB, I get score in here. I have increase some score. Also my testing score is also nearly same, 4001. So here I can see that the model get little bit regularized, because if I increase the error, that means my model is performing good on training data. Also it is fine on the testing data, but also the difference is kind of 3,005. Again, I am performing another gift search here to find the base model, as I am not getting a satisfactory result from here error. Here I am see that in case my training error getting increase, also testing error getting increase. So that's why I decided to plotting some graph here on this model, which is I found on the second time gift CB. Here I can see that training data is very fine. Most of the data all are on the predicted mostly correctly, but testing is not that much. There are some dispersion on the data set. So I can tell that this data is slightly overfit. Now I'm checking the R2 square. Here I can see the R2 square is almost 100%, because 99.997. So there is no error. I can say there is no error on the training, but there is slightly 5% of error on the testing. I cannot say that much this is overfit, but the error is also very far. That's why I choose to leave this. Now I'm checking the residual. The residual error is very narrower here compared to others. All the data are 0, meaning there is almost no difference on the prediction and target data. Now I'm checking the create another DFEVL data frame on the last git search model. Here I'm checking the difference. The mean difference is almost 0. The maximum difference is 960. Now this get increased. First, initially my base model, if I go to the top on the base model, my base model give me difference is 510, but after the searching for the base parameter, my base model difference get increased. So I decided to stay on the base model. So now I have saved the base model as it that I have saved in the first one. So I have decided to use the first one as it give me more generalized result. This model I have decided to keep this model.